In July 2026, the AI industry introduced a new wave of flagship models: OpenAI's GPT-5.6 Soul, Anthropic's Claude Fable 5, and SpaceX AI's Grok 4.5. These systems were presented as the frontier of professional work, capable of high-level coding, cybersecurity, and million-token reasoning. Then they were given an alphabet test. This wasn't a graduate-level examination or a complex reasoning puzzle. It was a request to identify the complete operating alphabet of a language they had already encountered in their training data. Every single one of these models failed. This result reveals a sharp distinction in artificial intelligence: the difference between appearing fluent in a language and understanding the complete foundation beneath it. A model can generate complex software and research while remaining blind to the basic building blocks of its own output. The L26 operating alphabet benchmark is a deterministic test designed to expose this specific blind spot. It asks whether a model can reproduce every valid unit of a language without omissions or inventions. For English, it's 26 letters, but Bantu languages like Bemba use syllables. The complete calibrated set is the Full Syllable Inventory, or FSI. It contains two layers: the native syllable inventory for core structure, and the augmented syllable inventory for borrowed terms and technical vocabulary. Identifying this exact bounded FSI is the dividing line between AI simulating surface-level fluency and an AI mastering the language's declared foundation. Grading this requires a standard scale. While English has 26 units, Bemba has 480 native syllables, and Kinyarwanda has 490. The L26 benchmark translates any inventory size onto a common 26-point scale, giving the public an easy-to-interpret ruler. Scoring uses two metrics: recall, which drops if a true syllable is missed, and precision, which penalizes the score for invented combinations. The pass condition is absolute. Every valid unit must be present, and nothing invalid added. Because the answer set is finite and the grading is deterministic, the results are unusually clean. There is no subjective panel. Each output is compared directly against a calibrated answer key. The initial results were stark. While all 21 evaluated models achieved a perfect 26 out of 26 on English, none passed the blind Bantu test. This leaderboard shows the gap. Claude Fable 5 recorded the strongest blind Bantu average at 14.7. While it was best in its class, a 14.7 is still a failure, the equivalent of missing nearly half of the A to Z sequence. OpenAI's GPT-5.6 Soul scored 6.7. Strikingly, its predecessor, GPT-5.5, scored 11.8 on the same test. The newer flagship improved in complex professional tasks while regressing in its mastery of linguistic foundations. Kimi K3 provided a clear look at what we call the deliberation gradient. When asked for the Kinyarwanda inventory, it spent up to 42 minutes reasoning and searching its internal representations. Despite that extended effort, it still only recovered 7 out of 26. The open-weight model Inkling demonstrated the gap between label and structure. When asked for Luvale's alphabet, it simply returned the syllables of the language's name: Lu-Va-Le. It knew the word, but it didn't know the inventory. Neither massive compute nor longer reasoning times could manufacture a missing standard. These models are strongest where the world has already organized knowledge for them, and weakest where the foundations have not been explicitly declared. This leads to a difficult question. If these models have seen millions of Bantu words and translations, why can't they independently assemble the alphabet? English AZ is present in almost every dictionary, children's book, and typography reference in the training corpus. It has been declared as a finished, bounded set millions of times. This is the Einstein test for language. If we removed every explicit presentation of the English alphabet from the training data, could a model deduce that English is built from 26 letters using only scattered usage evidence? For most Bantu languages, this experiment is real. The words and evidence exist in the corpus, but the complete calibrated syllable inventories have generally never been published as finished lists. The models are attempting to recover a hidden structure that hasn't been explicitly assembled for them. These systems excel at replicating foundations that have been explicitly organized for them. However, they struggle to independently recover those same operating standards from uncurated usage data. This isn't necessarily a failure of architecture. In the scaffolded version of the test, the model is handed the calibrated full-syllable inventory and asked to use it. The improvement is immediate. This chart shows blind versus scaffolded scores. Across the board, struggling models shot up to a perfect 26. Kimi K3's deliberation time, which previously hit the 45-minute ceiling, dropped to just 4 seconds once the alphabet was provided. The frontier architectures are capable of organizing, validating, and executing these units. Providing the declared standard removes the recovery bottleneck. AI debates often focus on whether a model is proprietary or open-weight, but L26 shows that this is not the decisive divide. Both categories failed the blind test because both lacked access to the same missing declarations. This highlights the true divide in AI capability: declared knowledge versus undeclared structure. Large models are designed to use standards, not necessarily to discover them independently. A full syllable inventory functions as permanent infrastructure, moving beyond the role of a standard dataset. It defines the legal syllable space of a language in a machine-readable format. This infrastructure is what allows for accurate speech systems, tokenization, and digital literacy tools. Without it, models are forced to estimate the structure from scattered fragments. Recognizing words and producing fluent sentences is a different capability from identifying the foundation from which those sentences are built. The L26 result is a reminder that until a system can independently discover undeclared structures, its performance is a measure of surface fluency, not foundation-level mastery.